another question in proportion. It has got Joule's law, Ohm's law and all that. We need not be confused about that, okay? If we see Ohm's law, Joule's law, we might think that this is based on science, which it is. But then even if you don't know Ohm's law and Joule's law, you can do this question. Ohm's law can be combined with Joule's law to show that power varies directly as the square of electric current. So power varies as I square, where P is power and I is the electric current. So power varies as I square. So power varies directly as the square of the electric current when the resistance is constant, and it varies directly as resistance when the current is constant. So it is another question on joint variation. So power varies as I square, where I is the current, into R, where R is the resistance. In an experiment involving two separate circuits, it was found that the ratio of power across circuit 1 to circuit 2 was 3:5. So P1 by P2 is 3:5. Ratio of power across circuit 1 to circuit 2 was 3:5. And the resistance in circuit 1 and circuit 2 were in the ratio 5:12. Find the ratio of the current across the two circuits. So basically P proportional to I square R, or P equal to K1 into I square R, where K1 is a constant in this question, which is called the constant of proportionality. So we can write by transposing I square equal to I by K1 into P by R, or I equal to K2. 1 by K1 is taken as K2 into square root of P by R. So I1 by I2 will be K2 into root over P1 by R1 divided by K2 into root over P2 by R2. And K2 gets cancelled. So I1 I2 will be square root of P1 by P2 into R2 by R1. Now we are given that P1 by P2 is 3 by 5 and R1 by R2 is 5 by 12. So R2 by R1 will be 12 by 5. So I1 by I2 will be root over 3 by 5 into 12 by 5, which gives us 36 by 25 or 6:5. So current I1 to current I2 will be in the ratio 6:5.